Welcome back, everybody. Here's Decay Factor and Decay Rate. All right, so here's the next worksheet. We did the growth rate and growth factor. Here's the decay rate and decay factor work part of this worksheet. So let's take a look. So very similar to what we did before, right? So we have y equals 2 times the quantity of 0.25 to the x power. Let's get this first 2 out of the way. That's my initial starting point, right? There's my c. All right, that's not going to change for any of these, right? So that's all 10, and then the 2500, right? That's not going to change. That's always going to be my initial starting value. So let's get that out of the way. All right, so the decay factor, okay, is always going to be the number inside the parentheses. So 0.25, 0.38, and 0.94. Right, this is what I'm multiplying by every time to get to the next y value, right? So on my table, I'm going to take whatever y value, whatever output I have, I'm going to multiply the next one by 0.25 to get to, and go down. You'll see your numbers going down, and 0.38, right? But the decay rate is now what? Okay, so this one's a little tricky. For the growth rate, okay, we just took I'm going to take that 1 point, I'm going to take my growth factor, I subtract 1, and I get 0.25. That was my growth rate. So now here's my decay rate, okay? So I could look at I guess I could take 0.25, my growth factor, subtract 1, and I'll get 0.75, or negative. And it should be negative because it's my decay rate. So I'm decreasing. I don't have to write the negative sign because I'm implying that by a decay. So my decay rate is 0.75. Do the same thing here for number 20. So I start with 0.38. I subtract 1. And I get 0, or I'll get a, let me go negative. I'll get a negative 0.62. So my decay, right, that's the negative sign, is just 6.2. And then the last one, 0.94 minus 1, and I get negative 0.06. So 0.06 is my decay rate. Now you could always convert these into percents. So I'm going to move this over. So my decay rate is 0.75 or 75% decay rate. For number 20, 0.62 or a 62% decay rate. And the last one, 0.06 or a 6% decay rate. All right, so similar fashion, and I did 0.25 minus 1 to show the negative. I could have done 1 minus 0.25 and still got 0.75, but I just want to emphasize that this is going to be negative, right? So I'm starting at 1, I came down to 25, so it went down. How much did it go down by? It went down by 75%. All right, and that's the decay factor, decay rate, and the initial starting point. Let's take a look at a little more examples here, right? So now, given the decay rate, right? So this is what I have, 15%. Decay starts with D, so it does decrease. Right, so you're always starting at 100%, and then I'm going to decrease or deduct something, right? 100% minus what? Well, on the first one, it's going to be 100% minus 15%, which is equal to 85%. So my decay factor is 0.85 when I convert this into a decimal. All right, next, I start with 100%. I take away or subtract my 66%, and I'm left with 34%. So my decay factor is 0.34. That's given the decay rate, find the decay factor. Given the decay factor, find the decay rate, right? So the decay factor, again, is the number that's inside the quantity here, right? The number that's raised to whatever power. That's the decay factor. So I have 0.22 as my decay factor. Right? I subtracted 1 from something. I did 1 minus some decay rate, and I get my decay factor. Or you can kind of reverse the order on this one, right? So you're going to have your decay factor, subtract 1, and this should give you the negative rate, right? So then if I take 0.22 and I subtract 1 from this, I get 0.78 negative. And since it's a decay rate, I'm just going to say my decay rate was 0.78 or 78% decay. And again, whether I do 0.22 minus 1 or 1 minus 0.22, I'm going to get the same answer. Alright, so 1 minus 0.82 is equal to 0.18. So my decay rate is 18%. Where's that? Okay. 65% is my decay factor, so I'm going to say 1 minus 0.65 equals 0.35, so my decay rate is 35%. Alright, so 0.22 minus 1 or 1 minus 0.22 gives you the same thing. Just recognize that, if you're looking at the negative side, that's why it's negative, because it's a decay rate. Or if you did it the other way, just recognize it's coming from 100%, right? You're always starting 100%, and I'm going down to this new number. How did I get there? What did I take away? The decay rate is what I took away from my 100%. Alright, so there's this worksheet on decay rate and decay factor. I'm going to do a couple more. See what we have here on the next page. We have next page is extra practice. Right, I'm not going to do them all. There's some. All the answer keys are online already, but we'll play around with a few. Let's see what we have here. So we have classify for numbers 5 through 10. Classify the models of growth, exponential growth, decay. Identify the growth rate or decay factor, and the percent increase or decrease per period. Alright, so I'm going to look at the first 5 here, okay? So let's just look at number 5. We got y equals 0.05 times 10 to the t power. Alright, so growth or decay, and that depends on your b value, right? This is your b value. So if b is greater than 1, then it's growth. Right? And the other one was if b is between 0 and 1, then it's decay. Right? So if it's a decimal between 0 and 1, it's a decay, right? It has to be between 0 and 1. Alright? So we established that this is growth. Then it's asking me for the decay factor, growth or decay factor. Well, in this case, it's going to be a growth factor. So my growth factor is going to be my b value. So my b value is my growth factor, 10. And then it says ask for the percent of increase, or really it's just asking for the growth rate. So I'm going to take my decay factor, I'm going to subtract the 1 that I start with, and I have 9. So 9 as a percent is moving a decimal over twice, and you have 900% increase. Right? So it's 10, right? My growth factor is 10. Take away the 100%. So remember, I start with 100%. It's growth. It's growth. So I add 900%, and I get 1000%, or 10, which is how I get my growth factor of 10. Alright, and then the other ones are similar to this one. And you can look at any one of these. Just keep in mind, so if you look at number 6, right, now you have a b value of 1/3, so that's between 0 and 1, so this is growth, exponential decay, right? So then it's asking for the growth factor, or I'm sorry, decay factor. is going to be 3. And then, actually, sorry about that. Let's erase everything I just said. My bad. 1/3 is the initial, right, where I start. 3 is my growth factor. Oh, get that. And then my growth rate, I'll put GR for initial, for abbreviation, GR, is going to be 3 minus 1, or 2, therefore move my decimal over twice, 1, 2, and I get 200% as a growth rate. All right, let's do one more that has a decay instead. Steal this one, number 9 here. Screen down a little bit, okay. All right, so now my B value is 2/3, and that happens to fall between 0 and 1, so this is decay, right? My initial value is still 1.5, right? That's my y-intercept. Nothing's going to change there. Then I need the decay rate. All right, so I start at 1. I am now at 2/3. So if I do 1 minus 2/3, I get 1/3. So I decreased by 1/3, or 33.3% repeating rate. All right, so I had 100%. I'm at 2/3 now. I got to 2/3 by deducting 1/3 from my 100. So my decay rate is 1/3, or 33 1/3% if you write it as a percent. All right, and let's look at what else we got on here. There's a couple more on here I'll let you guys practice with, but here's one more we'll do together, number 15. So we got number of students who applied for internet has tripled each month. All right, so there's your B value, right? It's tripling each month. So, and then what is the percent of increase each month? Okay, well, if this is your growth factor, remember, so I got 3 minus 1 equals 2, so I'm increasing 200% is the percent of increase. And if 45 students initially, right, there's my initially, so now I can write an equation, y equals 45, right, which is the A value, times my tripling each month to the x power, or my B value to the x power. And then it says how many had privileges 4 months later, so x is months. And we have y equals 45 times 3 to the 4th power. All right, just make sure you're doing 3 to the 4th power first, and 3 to the 4th power is going to be 81. And let me just get my calculator going here. So we got 3 to the 4th, 81, and times 45. And you can put this right into your calculator in one keystroke, and you get 3645. So 3,645 students. All right, so that's pretty much decay from here on in, and we got one more section to do. I'm going to talk a little bit about graphing functions, but I'll see you on the next video for that one. See you guys later.